Okay, section 7.3, right, is sort of a companion section to 7.2. It's essentially the same types of problems, but now we're using a proportion setup rather than an equation setup. We're going to use the same kind of vocabulary. We're going to, use the percentage and the whole and the part as kind of our three references. But the setup here, right, so to get a proportion would be sort of two equal ratios or two equal fractions. And so the setup here is just going to be the percentage divided by 100, right? That makes sense because your percentage is sort of a number out of 100 anyway, is going to be equal to the part divided by the whole. Honestly, this is probably a much more intuitive setup and a way to kind of solve these problems than the equation. The equation is, I think the equation setup works nicely in as much as sort of turning the word problem kind of directly into an equation, using this kind of is becomes equals, of becomes multiply, right? The percent and the part and the whole, in a way of just sort of going word for word and almost like you're translating a language. I think the equation works well there. Conceptually, I think maybe the proportion makes a little bit more sense because obviously the part is out of the whole, the part over the whole, right? And the percentage is a number out of 100. So you kind of have all of that stuff sort of laid out here. And the ideas are just equal to each other. So we're going to be able to solve this using cross multiply, just like we did when we were doing the proportions in chapter 6. And so it's a matter of, so let's throw an example down here. So like 80% of what number is 4.8? Whoops. Question mark, not 4.8%, right? The percent is only showing up once. So the idea here is just to sort of, take our question, sort of identify, right, the three different things. Obviously 80%, right, is our percentage, of what number. So what number here is my x, is my unknown, and it's of, right, so it's out of. So that would be the whole, and so is 4.8, right, is usually signifies the part, and that is our sort of third piece here, right? We've got the other two identified. So then written as a proportion, right, the setup is going to be, so 80%, so then my setup is, so 80%, right, was 80 out of 100 is equal to, so in this case, right, the part is 4.8 out of what number? So then my x is down here on the bottom. Right, so I just get a pretty standard proportion. I'm just going to solve it by cross multiplying. Cross multiply to solve. So for us, right, this is going to be, x times the 80. 80 times x is going to equal 100 times 4.8. So this is like, okay, so 80x is, 100 times 4.8, 480, I guess, right? And so then to get the x, you're just doing a quick division by 80. You're sort of saying, okay, so this is, x, 480 over 80, the sort of zeros go. So this is really like a 48 over 8, which would be 6 essentially, right? So your whole value here, the missing value, your x, is going to be 6. And you're good to go. So kind of using this setup, we're able to just solve it with cross multiply. In theory, you could actually sort of cross multiply out, and at some point, around here, if you kind of kept this instead of 80, if you did this as, 80 divided by 100 is 0.80, and you brought the x over, it actually then just becomes the equation setup, your percentage times your whole from the bottom, right? If you kind of cross multiply the whole over here, you just end up with the equation setup, right? So in some senses, these are really just two different ways of approaching the same equation anyway. But it's kind of all about, perspective and just sort of which of these setups and sort of how to go about it, I think makes the most sense to you. Let's do the same thing we did in the last example. Let's run a few more so we can kind of see ourselves solve for all the different things. So that was solving for what? The whole. So how about something like, what number is 160% of 25? Question mark. So what number, right? So is our x 160%, right? So obviously the percentage here is our percent of 25, right? This sort of means out of. So of 25, the of sort of sets apart the whole, right? Sets off the whole. So then kind of by process of elimination, it must mean our what number. What we're solving for here is the part. So what number is 160% of 125? So then my setup, right, as a proportion. So 160%, 160 over 100, right? The percentage over 100 should be equal to x the part over 25 the whole. Quick conceptual question, right? In this case, the percentage is over 100%. So this is going to be one of the instances where the part is actually a bigger number than the whole, right? Because you can see this in the proportion, 160 over 100, the numerator value here is going to be bigger. So I'm going to expect a bigger number here than 25. So part of this is, don't let yourself necessarily get confused or turned around about what's going on here, right? We're going to get a bigger value, but that's kind of as expected. So 25 times 160 equals, right, 100 times x. Gosh, what the heck is 25 times 160? It's going to be like 4,000 or something. Maybe even bigger than that. Not bigger, just 4,000, just regular 4,000. So that's 4,000 is 100 times x, right? I just need to divide by the 100 to get my x. Of course, that's the one of the nicest numbers to divide by. We're just going to cross 2 zeros off of there. So this means for us, our x value here, the part is going to be 40. And again, that makes sense, right? Because in this case, the percentage is bigger than 100. So the part, we're going to expect to be bigger than the whole, bigger than the 25. And that's what we've got. So that would be an instance where we're solving for the part. What did we do? So what are we missing? Solve for the percentage. Let's do one more then. How about 1.8 out of 45 is what percent? So same as always, right? We got three things. What percent? So the what obviously is our x, and that's going to be our percentage. This is an interesting one. This is a case in particular where I actually really like the proportion as a setup better than the equation if you're solving for the percentage. If you remember in the equation when we had to solve for the percentage, we kind of had to solve for, sort of ended up with a decimal or a fraction version of it, and then had to convert it into a percent. In this case, because it's already set up as over 100, we don't need to worry about doing any kind of a conversion. Just whatever we get for x here will be the percent, and we're not going to have to sort of do any extra thinking about it. So that's an advantage. 1.8 here versus the 45. This is 1.8 out of 45, so out of 45. That must mean, right, out of the whole, and that the 1.8 is going to be our part. I think also this is a case where, excuse me, the proportion setup I think is going to be maybe the most intuitive, right? So, x percent out of 100 is going to be equivalent to, right, a 1.8 out of 45, right? Something kind of like that. We can cross multiply to solve. So this is, 45 times x is going to be 100 times 1.8. This for us would mean, right, 45 times x, this would be 180. And then just a quick division. We're going to get x here is 4, right? This would go 45, times 2 would be 90, and then times 2 again would be 180. So the x here is 4%, right? No conversion necessary because we're starting with a value that's out of 100. So I would say this is a great example of where using the proportion is a little bit easier. The version that I actually kind of prefer the equation to is if you're solving for the part, because the equation is sort of set up where you're multiplying the percentage times the whole is just equal to the part. So in those instances, I think using the equation is maybe the fastest way to go, because you can just do a quick multiplication and you're there. And then I guess that leaves what? Solving for the whole? I guess you could kind of run it either way. It's sort of whichever of these kind of techniques you prefer. Again, in theory, right, you can sort of do any of the proportion or the equation to solve kind of all three versions of this. Sometimes maybe it just depends on the numbers. If it's a more decimally type problem, if you're sort of starting with decimal numbers, maybe the equation is a little bit easier to work with, rather than having sort of a bunch of decimals and sort of fractions in the mix. But in theory, any of these versions of the equation, or the proportion, you can kind of use to solve any versions of these setups. So that's the idea. So that's sort of 7.3, really just sort of a one and done on the video. Good luck, have fun, and we'll see you next time.